Okay, here we are. These are notes over magnitude of vectors. We're going to solve them algebraically. So instead of using a ruler, we're going to use a formula. Our essential question is, how do we determine the magnitude of a vector algebraically? And so we're going to jump right into the first example. By the way, I want to point out to you over here on the left side of your notes, this is the symbol that we use for finding the magnitude of a vector. It looks like absolute value bars. That's all that it is. So when you see that in the problem, don't let it freak you out. It just means magnitude. So on our example, it says determine the magnitude of a vector xy from the point x, which is -3, 5, to the point y, which is 4, -2. You'll notice that I have the points labeled x1, y1, x2, y2. I drew for you a graphic so you could see what this vector looks like. The point -3, 5 for x is over here in the second quadrant. The point 4, -2 for y is over here in the fourth quadrant. And the vector is going from x to y. You'll notice that the arrow, remember, vectors represent magnitude and direction. So I have a length and I have a direction denoted by the arrow. Also, something I want you to be aware of, this little symbol, the little kind of half arrow thing, that's the vector symbol. Okay, so when you see that, don't freak out. It's just a vector symbol. That's all that it means. It's signifying that it's a vector. So to find this distance here, we're going to use something called the distance formula, which you should remember from geometry and algebra 2. If you're looking at it graphically, if it's graphed, you could use the Pythagorean theorem. This would be your A value, this would be your B value, and you're just squaring them, adding them together, and then taking the square root. But anyway, this distance here is the difference of the y's, which you'll see right here in the formula. And then this other distance on the horizontal is your difference of your x's, which you can see right here in your formula. And so when we plug the numbers in, we don't have to graph it every time to find this. We can just plug them in directly and see what we get. So let's go ahead and do that. So the first thing we're going to do is we're going to take our square root symbol. Don't forget the square root symbol. We are finding the magnitude of vector xy, and so we're plugging it into the formula. The formula says take x2 and subtract x1. Well, x2 is 4, and we are subtracting x1, which is -3. And then we're going to square that. Now it does not matter whether this is x1 and this is x2 or vice versa. You could have called this x2 and this x1. That does not matter. Just be consistent. Because this is x2, then the one right next to it is y2. And because this is x1, this is y1. If I switch them, this is x2, y2, this is x1, y1. Now we're going to add to that the subtraction of the y's. Now I take my second y value, -2, and I subtract away my first y value, which is 5. So -2, take away 5, I square that. And when I simplify my numbers, 4 take away a -3 becomes 4 plus 3, which is 7. 7 squared is going to give me a particular value. And then over here I've got -2 minus 5. Well, that's a -7. And when I square that, I'm going to get another value. Now if you're putting this in your calculator, when you square a negative, you need to make sure there's parentheses around the negative so that when you square it, it becomes positive. Otherwise, you will get the wrong answer every time. 7 squared is 49. -7 squared is also 49. And when I add those together, I get the square root of 98. And the square root of 98 is approximately 9.9. And that is my final answer. Let's go ahead and pause, copy that down, and then get started on the try this that is right underneath this. Okay, go ahead and work on the try this. You are determining the magnitude of vector xy for x, -3, 1, and y, -2, -6. So see if you can determine the magnitude. I will post the answer in a few minutes. Okay, welcome back. You should have gotten that the magnitude of xy was approximately 7.1. Remember, we're rounding to one place behind the decimal point. When you plugged in, you had -3 minus a -2. You got -1 from that. Remember that the negatives, double negatives here, become positive. You can put this directly in your calculator, so there should be no problem with your arithmetic. 1 minus a -6 becomes a +7. And then when I square those, I get +1 plus 49, which is square root of 50, and then I end up with 7.1. Okay, let's go ahead and pause, make sure you've got that in your spiral, and then we'll go to a second example, and then you'll work on your work. Okay, second and last example. Determine the magnitude of AB for A, 374, and B, 2, -6, -5. And you'll notice that this is a three-dimensional set of points, so when we do this, we're going to have a three-dimensional distance that we're going to be finding. We do it exactly the same way. I'm still going to subtract my x's, I'm going to subtract my y's, I'm going to subtract my z's. Okay, so on this one I'm going to call this x2, y2, z2, and this is x1, y1, z1. So when I plug in, I'm still subtracting my x's, so I've got 3 take away 2. Squared plus subtracting my y's, 7 take away a -6 squared plus subtracting my z's, 4 take away -5 squared. Simplifying, double negative here, double negative here, those become positive. This one, that's not a double negative, so that stays a minus. Now we're going to simplify. 3 take away 2 is 1 squared. 7 plus 6 is 13 squared. And 4 plus 5 is 9. And then we're going to square that. Simplifying a little further. 1 squared is 1. 13 squared is 169. 9 squared is 81. Now we're going to add all of these together. One plus 69 is 170, plus 81 is 251, which we want to take the square root of. If you're thinking about that, that's really close to 256, which square root of that is 16, so this answer is going to be really close to 16. It's probably going to be around 15.8, but let me go check it on the calculator. So hang on just a second. And 15.8 it is. So the magnitude of AB, it's a three-dimensional vector, is 15.8. Alright, so make sure you got this in your notes and continue on with your work. Make sure you get your work done today, and have a good afternoon. Bye-bye.